Hello. So this is the implementation of meal detection algorithm using CGM and bolus data with the help of SARIMA model. So SARIMA is nothing but an extension of ARIMA and stands for a seasonal autoregressive integrated moving average. And this basically explicitly supports time series data with a kind of seasonal component. The basic problem with ARIMA is that it does not support seasonal data. That is essentially a time series data with repeating cycle. ARIMA expects data to be either which is not seasonal or data which has its seasonal component removed. So for the implementation of this algorithm, I am using Google Colab and I have mounted it on the drive over here. So first of all, I am importing all the necessary libraries over here. Then in the next step, I am processing the data file. Now moving forward, since the provided data file is in .mat format, I am converting it into pandas data frame for its easy usage and so that it can be used easily. Now the data that we have is the CGM and bolus data along with their respective times of recording. So we need to synchronize these data based on their times of recording. So I am doing it by merging this data with 5 minutes of approximation, which is specified over here. After this operation, data of essentially this sort is obtained. So for the SARIMA algorithm, the time data is the index of the data frame, and also the frequency of the data frame is required to basically set the frequency of the data frame. So in this step over here, I am inferring the frequency and setting it for the data frame. Now we need to get the parameters of SARIMA. To determine these parameters, I am plotting the autocorrelation and the partial autocorrelation graphs. The autocorrelation plot is also called as ACF plot, and the partial autocorrelation plot is also called as PACF plot. The seasonal part of AR and MA model can be basically inferred from PACF and ACF plots. Here we can see that in the partial autocorrelation plot, we have a large spike in the positive side and one large spike in the negative side. The other spikes are very close to zero value, so they need not be considered for the non-seasonal order. Essentially, in the non-seasonal order, we can see that because of the positive spike, the MA factor is set to 1, and because of the negative spike, the AR factor is set to 1. Since the data in general does not have any upwards or kind of a downwards trend over the last time that we are taking into observation, so the differential factor over here can be set to 0 conveniently. Now after taking multiple periodic intervals, I came up with the conclusion that periodicity can be basically set to 5 hours, which is equal to 300 minutes. So this would mean that there are about 60 intervals of 5 minutes each. So I am setting this parameter over here to be as 60. After this, I have trained the model and fitted and then predicted it on the test data for which the output is obtained, and also the plot for the same is obtained. After this, I have trained the model and predicted it. Then I have moved on to calculate the mean absolute percent error, which comes out to be approximately 14% over here. Now I have forecasted the CGM data, so I can use this data to predict the meals of people. So for this, I am setting up a threshold value of 0.8 over here. Now I have taken the CGM data, and the bolus data and prediction data, and the process is to predict the bolus data and therefore the meals essentially. And this is again done by checking against the threshold value and this comes out to be our final data frames. Now at last I have taken into consideration all these data points and use it to find the accuracy. The accuracy of all this data that I have predicted comes to be around 70%. So we can say that we are able to predict meals using the CGM data and bolus data using the SARIMA algorithm with a good accuracy. Thank you.